so this is part 2 of Thursday for Algebra 2, properties of exponents. So I just went over the properties and now I'm going to do some examples. So the first example is if I had 10 to the 12 times 10 to the 35. Okay, so this is a product. They're both next to each other, and when they have the same base, you can just add. So we're going to take 12 plus 35 in the exponent, and so we get 10 to the 20, oh, I don't know why I said 20, 47. 10 to the 47 would be the answer. All right, another example is if I had x to the 0 and y to the negative 1. Well, this is the 0 property. Anything to the 0 is 1, so this x is gone. Then I just have y to the negative 1. And the negative property moves something into the denominator and makes it positive, so it'd be 1 over y to the 1 power. And typically you don't see us write the 1 power, so it would be 1 over y. All right, example 3. If I had 9x to the negative 10 z to the second times negative x to the 5 y cubed. So in this one, everything's being multiplied, but what we need to do is combine exponents that have the same base. So first of all, we've got 9 and negative 1. Those multiply to make negative 9. And I've got x to the negative 10 and x to the 5. So we're going to add that. Negative 10 plus 5 is negative 5. And then I've got y cubed. Notice I'm going alphabetical order. That's not necessary, but it's common that that's the way you report your answer. And then z squared is by itself. And now we have this negative exponent, so we can go even farther. We're going to keep negative 9, y and z in the top. So negative 9, y cubed, z squared, all over. This x is going to become x to the positive 5 in the denominator because of its negative exponent. Okay, another one. Here's example 4. A to the negative 5a squared. So these are right next to each other. They're being multiplied, so we're going to add. Negative 5 plus 2 is negative 3. And because it's negative, same thing, it's going to go in the denominator as a positive. 1 over a cubed. All right, just a few more. If I had x squared to the 3rd, I'd just multiply it. I'd have x to the 6th. If I had x over y to the negative 6, so everybody would get the negative 6, x to the negative 6, and y to the negative 6. And remember that our negative exponent just means that we flip-flop here. So we're going to put x with a positive 6 exponent in the denominator and y with a positive 6 in the numerator. That would be our final answer. And then one more problem. Y cubed 3z x squared over 9x cubed. Okay, first thing we need to do is give everybody this 2. 3 gets the 2, x and z. So it's going to be y cubed, 3 squared is 9, z squared, and x squared. If these had had exponents, we would have multiplied. So if it would have been like z to the 3, we would have done z to the 6, because 3 times 2 is 6. And then our numerator is 9x cubed. And now we just see what can cancel out. 9's cancel. And then nothing matches with y, it doesn't have any like terms. Z doesn't have any like terms. But we've got 2 x's in the top and 3 in the denominator, so we're going to subtract powers. 2 minus 3 is negative 1. We're going to have 1, and negative indicates that it's in the denominator, so it's going to stay there. So y cubed z squared over x. One way to think about it too is if you had x squared over x cubed, that gives you x to the negative 1, because 2 minus 3 is negative 1, which tells me it's 1 over x. A way to think about it is think about like this is heavier, there's more x's in the denominator, So once you simplify, an x is going to remain in the denominator. This is our answer. Okay, that's all the examples. I want you to try the assignment that I posted on Classroom, and I am going to link my key too. And then in the Zoom call today, I can answer any questions you have. Okay, thanks. Bye.